Okay, so here's something that should mess with your head before we even get started. Right now, tonight, you could walk outside, tilt your head back, and stare up at the Milky Way, feeling like you're looking at your whole home, the entire galaxy you were born into. And you would be seeing basically nothing. You can see roughly 0.00003% of the Milky Way with your naked eye. A few thousand stars out of over 100 billion. Nearly the entire galaxy you literally live inside of is invisible to you. That bright, peaceful, frozen band of light, it's a lie of scale. You're standing inside something so enormous and so violent that your eyes can only catch the faintest dusting of it. And if you're into this kind of brain-melting stuff, the cosmic horror that's actually just regular Tuesday for the universe, then yeah, hit subscribe. We post these every single week. You can smack the bell too if you want. No pressure. We'll just be over here quietly explaining why your home galaxy is a stitched-together monster. Cool? Cool. Let me explain. Because here's the thing you've got to wrap your head around first. You picture the galaxy as this fixed, ancient, peaceful spiral. Like a photo someone took once, and it's just been hanging there ever since. It is not. It's a violent, half-built thing. It was assembled out of the wreckage of smaller galaxies it tore apart and devoured. It's held together by an invisible substance nobody on Earth can identify, and by all the physics we actually understand, it should be flying apart right now. So buckle up, because we're going through 100 facts about the Milky Way, and basically every one of them is going to chip away at that pretty little picture in your head. Let's start with the basics. The stuff that sounds simple until you really sit with it. The Milky Way is a barred spiral galaxy. That word barred matters, and we'll get there. It's roughly 100,000 to 120,000 light-years across. Now, a light-year is the distance light travels in 1 year, and light moves at about 300,000 kilometers per second, the fastest thing there is. So when I tell you the galaxy is 100,000 light-years wide, I'm telling you that if you fired a beam of light across it, the fastest possible thing in existence, it would take 100,000 years to cross. You, sitting on your couch, are a speck inside a structure that light itself needs 1,000 centuries to traverse. That's not a place. That's a kind of geography that breaks your brain. And inside that span, you've got somewhere between 100 billion and 400 billion stars. We don't even know the number precisely. Think about that for a second. We can't count the stars in our own galaxy to within a couple hundred billion. That's how big and how hidden the place is. Most of those stars you will never see, never detect, never know existed, because they're buried behind gas, behind dust, behind sheer distance. Now, here's the part that always gets people. The Milky Way is so wide and so flat that we struggle to even know what it looks like from the outside. You've seen those gorgeous spiral galaxy photos, the swirling arms, the glowing core. We have never taken a photo like that of our own galaxy. We can't. We're stuck inside it. It's like trying to take a portrait of your own house while you're locked in one room of the basement. Everything we think we know about the shape of the Milky Way, the spiral arms, the central bar, all of it is reconstructed, inferred, pieced together from measuring distances and motions of stars we can see. The picture in the textbook is basically an educated reconstruction, an artist's best guess based on the data. We are mapping our home from the inside, blind by feel. And where are you in all this? You are not at the center. You're not special, locationally speaking. The Sun sits about 26,000 to 27,000 light-years out from the galactic center, parked on a minor spiral arm. Some people call it the Orion Arm, or the Orion Spur, and the word spur is doing a lot of honest work there, because it's not even one of the main grand arms. It's a little side branch, a feeder lane off the main highway. You live in the cosmic suburbs, the galactic countryside, out where it's quiet. And honestly, that's probably a good thing, and here's why. But let me explain that one in a bit, because where the action is, you really do not want to be. Let's talk about that center, because this is where the picture goes from peaceful to terrifying real fast. At the heart of the Milky Way, right in the middle of everything, sits a supermassive black hole. It has a name, Sagittarius A star, written with an asterisk, and astronomers actually say it out loud as Sagittarius A star. And this thing is about 4 million times the mass of our Sun. 4 million suns crushed down into a single point of gravity so intense that not even light can escape it. And here's the crazy part. All of that mass, 4 million suns worth, is crammed into a region of space smaller than the orbit of Mercury. Mercury, the closest planet to our Sun, whips around in a tight little orbit. Take that entire orbit, that whole region, and now imagine 4 million suns packed inside it. That's the monster at the center of your galaxy. And in 2022, humanity actually photographed it. We got an image of the shadow of Sagittarius A star, the dark silhouette ringed by glowing, superheated gas spiraling in toward its doom. We took a picture of the thing eating the heart of our home. Now, you might think a black hole that size is just sitting there quietly, sucking everything in like a cosmic drain. And here's where you'd be wrong in the most spectacular way. This black hole, and the chaos around it, sometimes flings stars out of the galaxy entirely. There's a whole category of objects called hypervelocity stars. These are stars that got too close to the gravitational madness at the center, got slingshotted, and are now screaming outward at over 1 million kilometers per hour. 1 million kilometers an hour. These stars are being ejected, kicked clean out of the Milky Way, doomed to wander the empty dark between galaxies forever. So no, the center isn't a quiet drain. It's a gravitational slingshot violent enough to launch entire suns into exile. Still glad you live in the suburbs? Yeah, thought so. And here's the thing about that center that I love. You can't see it. Not the actual core. If you look toward the constellation Sagittarius, you're looking toward the heart of the galaxy. But between you and it sit thick clouds of gas and dust, dense enough to block visible light almost completely. The center of your own galaxy is hidden from your eyes behind a curtain of dust. We only know what's there because we look in infrared and radio waves and X-rays, wavelengths that punch through the dust. In ordinary visible light, the place you'd most want to see, the dramatic glowing core, is just blocked. Cloaked. The galaxy keeps its own heart secret from you. Okay, so now let's get to the part that genuinely keeps physicists up at night. I told you the galaxy should be flying apart. I meant it literally. Here's the deal. When something orbits something else, like a planet around the sun, the speed it needs to stay in a stable orbit depends on how much mass is pulling on it. The outer planets move slower than the inner planets because gravity gets weaker the farther out you go. That's just how orbits work. It's clean, it's predictable. We've known it since Newton. So when astronomers measured how fast the outer stars of the Milky Way are spinning around the galactic center, they expected those outer stars to be moving slowly, just like the outer planets in our solar system. And instead, the outer stars were moving way too fast. Stupidly fast. So fast that the visible mass of the galaxy, all those hundreds of billions of stars and all that gas, doesn't have nearly enough gravity to hold on to them. By the actual numbers, those outer stars should have flung themselves off into intergalactic space billions of years ago. The galaxy, by all known physics, should have torn itself apart. But it didn't. It's still here. You're still here. So something is holding it together. Something with a massive gravitational grip that we cannot see, cannot touch, and cannot identify. We call it dark matter. And that name, dark matter, makes it sound like we know what it is. We do not. The name is basically a placeholder for our ignorance. It means there is matter out there, exerting gravity, holding the galaxy together, and it is dark to us in every possible way. It doesn't glow, it doesn't reflect, it doesn't block light, it doesn't interact with normal matter except through gravity. It's just there, an invisible scaffolding wrapped around and through the entire galaxy. And here's the part that should genuinely humble you. Dark matter outweighs everything we can see. All the stars, all the planets, all the gas, all the dust, every single thing in the Milky Way that gives off or blocks light, all of it combined is the minority. The dark matter halo surrounding our galaxy is estimated to hold something like 5 to 10 times more mass than all the visible stuff put together. The galaxy you can see is the foam on top of the wave. The real bulk of it, the real mass, is invisible and unidentified. You live inside a structure where the part you can perceive is basically a rounding error. So let that settle. The thing keeping your entire galaxy from disintegrating, the thing that outweighs all 100 billion plus stars several times over, is a substance that nobody, not the smartest physicists alive, with the best instruments ever built, can tell you the identity of. We've named it, we've measured its gravity, we've mapped where it has to be, and we still have no idea what it actually is. That's not a solved mystery. That's the biggest open question in physics, sitting right over your head every single night. Now, speaking of things being held together, let's talk about how this galaxy got built in the first place, because this is where the word cannibal comes in. And I'm not being dramatic for fun. Astronomers literally use that word. Our galaxy is a cannibal. The Milky Way did not just quietly condense out of one neat cloud of gas and stay that way. It grew by hunting. It grew by tearing apart smaller galaxies that wandered too close and devouring them, absorbing their stars, swallowing their gas, and adding them to its own bulk. This is called galactic cannibalism, and it's not ancient history. It's happening right now. There's a galaxy called the Sagittarius Dwarf Galaxy, a small companion galaxy, and the Milky Way is shredding it apart as we speak. Its stars are being pulled out into long streams, stretched and torn by the Milky Way's gravity, slowly getting dragged into and digested by our galaxy. It's a galaxy being eaten alive, in real time, and we're watching it happen. And here's the haunting part. The galaxy still wears the scars of its old meals. When the Milky Way devours a smaller galaxy, the victim's stars don't just blend in instantly. They get strung out into these long, faint, looping trails called stellar streams. Ghostly ribbons of stars, the leftover skeletons of galaxies that the Milky Way ate billions of years ago, still hanging in our sky. We can map them. We can trace these streams arcing across the heavens, and each one is basically a tombstone for a galaxy that no longer exists, a galaxy that the Milky Way hunted down and consumed. Your home is decorated with the ghosts of the things it killed. There's one of these ancient meals that's so big it has a name and a whole story. About 10 billion years ago, a substantial galaxy collided with and merged into the young Milky Way. Astronomers found the evidence in a huge population of stars, all moving in a strange, distinctive way, left over from that ancient collision. They named the devoured galaxy Gaia Enceladus, sometimes called the Gaia Sausage, because of the sausage-like shape its stars trace out in the data when you plot their motions. I'm not making that up. The Gaia Sausage is a real scientific term. The point is, a giant chunk of the Milky Way's inner halo, a big slice of the stars near us, are the digested remains of an entire other galaxy that our galaxy ate 10 billion years ago. You are surrounded by alien stars, refugees from a galaxy that died long before the sun was born. And that brings us to time, because the Milky Way is old. Genuinely, almost incomprehensibly old. The galaxy is estimated to be around 13.6 billion years old. To put that in perspective, the universe itself is about 13.8 billion years old, which means the Milky Way started forming just a couple hundred million years after the Big Bang, after the universe itself began. Our galaxy is nearly as old as everything. It's been around for almost the entire history of the cosmos. But here's the part that breaks the timeline in your head. Some stars in the Milky Way are older than the Milky Way itself. Let me say that again because it sounds impossible. There are stars inside our galaxy that are older than our galaxy. How? Because those stars formed in the very early universe, shortly after the Big Bang, before the Milky Way had fully assembled. They were born first, drifting in the young cosmos, and then later got swept up and incorporated into the galaxy as it formed and grew and ate its neighbors. There's one famous example astronomers nicknamed the Methuselah star, after the longest-lived figure in the Bible. And its estimated age is so high, it actually brushed up against the age of the universe itself, which caused a whole scientific headache, because a star obviously can't be older than the universe. The estimates have since been refined, but the point stands. Walking around inside the Milky Way are ancient stars, primordial relics that predate the galaxy holding them. The container is younger than some of its contents. Now, let's talk about your own place in this thing, your actual address, because the numbers here are genuinely insane. You know the Earth goes around the Sun once a year. That's our orbit. But the whole solar system, the Sun and all its planets, is also orbiting the center of the galaxy. We're being carried around the galactic center at a blistering speed, roughly 230 kilometers per second. That's about 800,000 kilometers per hour. Right now, as you sit there feeling perfectly still, you are being hurled around the galaxy at 800,000 kilometers an hour. You don't feel a thing. There's no wind, no rush, no sensation, because everything around you is moving along with you. But you are moving, fast, always, in a giant circle around a black hole 4 million times the mass of the Sun. And here's the thing about that orbit. It is slow. Galactically slow. One full lap of the Sun around the galaxy, one complete orbit, takes about 225 to 250 million years. Astronomers call this period a galactic year or a cosmic year. One galactic year is roughly 225 million Earth years. So when you measure the Sun's life, not in regular years, but in galactic years, the numbers get small and weird and beautiful. The Sun is about 4.6 billion years old. Divide that by the length of one galactic year, and you get this. In the entire life of our Sun, from its birth 4.6 billion years ago until today, we have only completed about 20 orbits of the galaxy. 20 laps. The Sun has gone around the Milky Way roughly 20 times total, ever. That's it. Your star, ancient as it is barely 20 galactic years old. It's practically a teenager on the cosmic clock. And here's the detail that always gets me. Because one lap takes 225 million years, you can map Earth's history onto the galaxy's rotation. When the very first dinosaurs appeared on Earth, around 230 million years ago, the solar system was on the opposite side of the galaxy from where it is now. We've gone almost exactly one full lap since the dawn of the dinosaurs. The last time the Sun was in this exact spot in its orbit, the first dinosaurs were just showing up on a young Earth. Think about everything that's happened since then. The entire age of dinosaurs, the asteroid that wiped them out, the rise of mammals, the whole sweep of human history, every empire, every war, every person who ever lived, all of it fits inside a single lap of the Sun around the galaxy. One galactic year contains all of recorded existence and then some. That's the timescale you're living on, whether you feel it or not. Now, speaking of motion, let me clear up something you probably picture wrong. When you imagine the solar system, you probably see the classic flat diagram, The sun in the middle, the planets going around it in neat circles on a tabletop. And then the whole thing slides through space sideways, like a frisbee flying flat. That's the image in most people's heads, and it's not quite how the journey actually feels in motion. Because the solar system's orbital plane is tilted relative to the direction we're traveling through the galaxy, so as the sun barrels along its galactic orbit, dragging all the planets with it, the planets trace out long, corkscrewing helical paths through space. We're not gliding flat, we're spiraling forward, a moving vortex of worlds, drilling through the galaxy at 800,000 kilometers an hour. Your planet's true path through space isn't a circle, it's a spring-shaped spiral that never once retraces itself. You have never been in this exact spot in the universe before, and you never will be again. Let's go back to structure for a second, because I promised you the word barred would matter. The Milky Way is a barred spiral galaxy. That means at the center, it's not just a round, glowing blob with arms coming off it. There's an elongated bar of stars, a sort of straight, brick-shaped concentration of stars cutting through the core. And the spiral arms trail off from the ends of that bar. For a long time, we weren't even sure our galaxy had a bar, because, again, we're stuck inside it and can't see the shape directly. But the evidence built up, and now we're pretty confident. You live in a barred spiral. The central bar funnels gas inward, feeding the core, and possibly feeding that monster black hole. The architecture of the galaxy isn't random. It's a dynamic, churning machine, moving gas and stars around on scales of hundreds of millions of years. And those spiral arms, here's a fact that genuinely surprised me when I first learned it. The spiral arms are not fixed structures made of the same stars locked in place. They're more like traffic jams, cosmic traffic jams. The arms are density waves, regions where matter piles up and moves slower, and stars drift in and out of them over time, the same way cars pile up in a jam on the highway and then eventually move through it. The arm itself stays roughly in place as a pattern, but the individual stars flow through it. So the beautiful spiral pattern you picture isn't a permanent pinwheel of the same stars frozen forever. It's a rolling wave, a pattern of congestion sweeping through the galactic disk, with stars constantly entering and leaving. The sun itself drifts in and out of the spiral arms over hundreds of millions of years. And those arms have names. The main ones include the Perseus arm, the Scutum Centaurus arm, the Sagittarius arm, and the Norma arm, with our little Orion spur tucked in between. When you look up at certain constellations, you're sometimes looking down the length of one of these arms, into a dense lane of stars and glowing gas and stellar nurseries, the regions where new stars are being born right now. Because yeah, the galaxy is still making stars. It's not a finished, static thing. New stars are forming all the time, born inside giant clouds of cold gas and dust called nebulae. These are the stellar nurseries, regions like the Orion Nebula, which you can actually spot as a faint fuzzy patch in the sword of the constellation Orion on a clear night. That little smudge is a factory where new suns are being assembled out of collapsing gas right now. The Milky Way produces, on average, somewhere around 1 to a few new stars per year. Doesn't sound like much, but over the galaxy's lifetime, that's how you build up hundreds of billions of them. And at the other end of a star's life, you get the violent stuff. When a massive star dies, it explodes as a supernova, one of the most energetic events in the entire universe. For a brief time, a single dying star can outshine the entire rest of the galaxy combined. All those hundreds of billions of stars and one exploding star can outshine all of them put together for a few weeks. These explosions seed the galaxy with heavy elements, and they leave behind exotic corpses, neutron stars, and black holes. And here's a wild one: neutron stars. When a big star collapses, its core can get crushed into a neutron star, an object so dense that a single sugar cube-sized piece of it would weigh about as much as the entire human population. Billions of tons packed into a teaspoon. The galaxy is littered with these dead, ultra-dense cinders, the leftover hearts of stars that already burned out. Some of those neutron stars spin fast. There are objects called pulsars, neutron stars that rotate incredibly rapidly and beam out radiation like a lighthouse, sweeping a beam past Earth so regularly that when we first detected them, the signals were so precise, so clockwork perfect, that astronomers briefly, half-jokingly, labeled the source LGM for Little Green Men, because the pulses were so regular they wondered if they'd caught an alien signal. They hadn't. It was a spinning dead star, whipping around dozens or even hundreds of times per second, more precise than most clocks we can build. That's the kind of thing floating around in your galaxy. Now let me hit you with the scale of distance again, because we throw around light years like they're nothing, and they are not nothing. The nearest star to our Sun is a system called Alpha Centauri, and the closest member, Proxima Centauri, is about 4.2 light years away. That's the closest other star there is, and to reach it with our fastest current spacecraft would take tens of thousands of years. Tens of thousands of years to reach the nearest neighbor, and that neighbor is right next door on galactic scales. The galaxy is 100,000 light-years across. The emptiness between stars is so vast that it makes the stars themselves feel like lonely little islands separated by oceans you could never cross in 1,000 lifetimes. Which, by the way, is exactly why the next fact is so strange and so reassuring at the same time. Because here's the thing, our galaxy is on a collision course. In about 4 to 4.5 billion years, the Milky Way is going to collide with our nearest large galactic neighbor, the Andromeda Galaxy. Andromeda is a massive spiral galaxy, even bigger than ours, and right now it's racing toward us at something like 110 kilometers per second. It's getting closer every second, and eventually the two galaxies are going to smash together in a slow-motion cosmic wreck that'll take hundreds of millions of years to fully play out. Now you'd think a collision between two galaxies, each with hundreds of billions of stars, would be the ultimate catastrophe. Stars smashing into stars, fireballs everywhere, total annihilation. And here's where you'd be wrong, and here's why it's so mind-bending. When the Milky Way and Andromeda collide, almost no stars will actually hit each other. Basically none. Because remember, the space between stars is so unbelievably vast. The stars are like a handful of grains of sand scattered across an entire continent. When you slam two continents worth of sand grains together, the grains themselves almost never touch. They just pass through the gaps. So the two galaxies will essentially flow through each other, their gravity warping and stretching both of them, flinging stars into long tidal tails, churning the gas, triggering bursts of new star formation, and over hundreds of millions of years, the two galaxies will merge into one single, larger galaxy. People sometimes call the future merged result Milkomeda, mashing the two names together. But your descendants, if any are around, are not going to see a sky full of colliding fireballs. They'll see the sky slowly, majestically transform as Andromeda grows from a faint smudge into a massive, luminous spiral filling the heavens before the two finally become one. It's not a war, it's a merger, a slow gravitational dance that ends in fusion. And here's the kicker on that. The Sun will almost certainly survive the whole thing. Our solar system is way out in the suburbs, remember? And with so few actual collisions, the Sun will most likely just get shuffled into a new orbit in the combined galaxy, possibly flung farther out, possibly tossed around, but intact. The galaxy you live in is going to be destroyed and reborn as something bigger, and your home star will ride through the apocalypse basically untouched. Turns out the end of the galaxy as we know it is survivable. if you're far enough out in the quiet lanes. The suburbs win again. Let me pull back and talk about light itself, because the Milky Way's name comes from light, from that band across the sky. The ancient Greeks looked up at that faint, glowing river of light stretching overhead and thought it looked like spilled milk, a milky road across the heavens. That's literally where the name comes from, the Latin Via Lactea, the Milky Way, the road of milk. And what you're actually seeing when you look at that band is the combined glow of billions of distant stars, too far away to pick out individually, all blurring together into a soft, luminous haze. You're looking edge-on through the flat disk of the galaxy, looking the long way through it, so all that distant starlight piles up into a band. When you look away from the band, up out of the disk, you see fewer stars because you're looking out the thin side of the galaxy into emptier space. But here's the heartbreaker. Most people alive today have never actually seen the Milky Way, not the real thing. Because of light pollution, the glow of cities drowning out the night sky, an estimated 1/3 of humanity, including the vast majority of people in places like Europe and North America, can no longer see the Milky Way at all from where they live. The band of light that every single one of your ancestors saw their entire lives, the sight that inspired myths and religions and the very name of our galaxy, has been erased from the sky for most of the modern world. You have to drive hours away from the city, out into real darkness, to see what every human for tens of thousands of years just saw automatically every clear night. We turned on the lights and we lost the galaxy. And when you do get out there, into true dark, and you finally see it, here's what you're really looking at. That dark rift running down the middle of the bright band, that's not empty space, that's dust. Vast lanes of dark molecular dust and gas lying between you and the stars behind them, blocking the light. The galaxy is full of this stuff, the interstellar medium, clouds of gas and dust drifting between the stars. It's thin, thinner than the best vacuum we can make on Earth, but there's so much of it spread across such enormous distances that it adds up to billions of suns worth of raw material. And that material is the stuff future stars are made of. The dark patches in the Milky Way aren't holes, they're the nurseries, the reservoirs, the cold, dark wombs where the next generation of stars is waiting to be born. Now I want to come back to that black hole at the center because there's more to say, and it ties into how we even know any of this. For decades, astronomers tracked individual stars orbiting the galactic center, watching them whip around an invisible point at incredible speeds. There's one star, called S2, that swings around the central black hole in a tight elliptical orbit, and at its closest approach, it's moving at something like several thousand kilometers per second, a serious fraction of the speed of light. By watching stars like S2 loop around an invisible something, astronomers calculated the mass of that something, 4 million suns, and confirmed it had to be a black hole, because nothing else could be that massive and that compact and that dark. That work, decades of painstaking observation, won a Nobel Prize in 2020. We figured out there's a 4 million solar mass black hole in our galaxy's heart by watching stars dance around the void for 20-something years. That's how you see the invisible. You watch what it does to the things you can see. Same trick we use for dark matter, just on a smaller scale. And here's something about Sagittarius A star that's almost funny given how terrifying it is. For a supermassive black hole, it's actually pretty quiet right now. It's not actively gorging on huge amounts of material, so it's relatively calm, just simmering. But it hasn't always been. There's evidence that a few million years ago, our galaxy's central black hole had a major outburst, blasting enormous bubbles of hot gas above and below the galactic plane. We call them the Fermi bubbles, after the telescope that found them, and they're gigantic, stretching tens of thousands of light years out from the center, glowing in gamma rays, the leftover scars of some violent event when the black hole was feeding hard. So the monster at the center isn't always sleepy. It goes through phases. It's eaten before, it'll eat again. And when it does, it lights up the galaxy in ways that would be terrifying to witness. Let me throw some more scale and texture at you, because the variety of stuff in this galaxy is genuinely staggering. There are stars out there so large that if you put one where our sun is, it would swallow the orbits of Mercury, Venus, Earth, Mars, and keep going. Hypergiant stars, like the famous ones, are so vast that the Earth's entire orbit would fit inside them with room to spare.
And on the other end, there are stars barely larger than a planet. Tiny, dim, red dwarfs, the most common type of star in the galaxy, burning so slowly and so faintly that they'll keep shining for trillions of years, far longer than the universe has even existed so far. Most of the stars in the Milky Way are these little red dwarfs, dim and long-lived and almost invisible to us. The bright, showy stars you can actually see are the rare exceptions. The typical resident of this galaxy is a small, dim, faint red ember that you'll never lay eyes on. And then there are the systems. You probably grew up thinking of a star as a lone object, like our sun, sitting by itself with its planets. But that's actually the minority arrangement. A huge fraction of the stars in the Milky Way come in pairs or groups. Binary stars, two suns orbiting each other, or even triple and quadruple systems, multiple suns locked in a gravitational dance. If you lived on a planet in one of those systems, you might have 2 or 3 suns in your sky, rising and setting in complicated, overlapping patterns. The single, solitary sun we have is, in a way, a little bit unusual. Companionship is the galactic norm. And planets. Oh, the planets. For most of human history, we knew of exactly one planetary system, our own, and we had no idea if planets around other stars even existed. Then, starting in the 1990s, we began finding them. Exoplanets, planets orbiting other stars. And now we've confirmed thousands of them, and the data suggests something staggering. On average, there is at least one planet for every star in the galaxy. At least one. Which means, with hundreds of billions of stars, there are hundreds of billions, likely trillions of planets in the Milky Way alone. Worlds beyond counting. Some of them are bizarre, planets made of diamond, planets where it rains molten glass sideways, planets so close to their star that a year lasts a few hours. Rogue planets with no star at all, just drifting alone in the dark between the stars. Your galaxy is absolutely crammed with worlds, an entire ocean of planets, almost none of which we will ever see or visit or know anything about. And a good chunk of those planets sit in what we call the habitable zone, the distance from a star where it's not too hot and not too cold, where liquid water could potentially exist. There could be billions of potentially habitable, roughly Earth-sized worlds scattered across the Milky Way. Billions of places where, maybe, the conditions for life as we understand it could exist. Whether any of them actually host life, we have absolutely no idea. But the real estate is there. The galaxy has set the table billions of times over. Which leads to one of the most haunting facts of all. And it's less a fact than a question that hangs over everything. With hundreds of billions of stars and trillions of planets and billions of potentially habitable worlds and a galaxy that's been around for over 13 billion years, where is everybody? This is the famous puzzle, the Great Silence. By all the numbers, the galaxy should be teeming with life, maybe even with civilizations. And yet, so far, we've heard nothing. No signals, no signs, no contact. Just silence. The galaxy is enormous and ancient and full of worlds, and as far as we can tell right now, eerily, profoundly quiet. Maybe we're early, maybe we're alone, maybe we're just not listening the right way. We don't know.
But the silence itself is one of the loudest facts about the Milky Way there is. Let me bring it back down to you, to your body, because this is maybe the most beautiful fact in the whole set, and it ties everything together. I told you stars forge heavy elements and scatter them when they die in supernovae. Here's why that matters to you, personally, physically. In the very beginning, the universe was almost entirely just hydrogen and helium, the two lightest, simplest elements. There was no carbon, no oxygen, no nitrogen, no iron, none of the stuff you're made of. All of that, every heavier element, was forged later, inside the cores of stars, cooked up by nuclear fusion over millions of years, and then blasted out into space when those stars died. So follow the chain. The carbon in your cells, the oxygen you're breathing right now, the calcium in your bones, the iron in your blood, every single one of those atoms was made inside a star. A star that lived and died billions of years ago, somewhere in this galaxy, forged those atoms in its core, and then, in its death, scattered them out across space. Those atoms drifted through the galaxy, got swept up into a cloud of gas and dust, and that cloud collapsed to form our sun, our Earth, and eventually, you. Every atom in your body was forged inside a star, scattered by its death, and gathered up into you. You are, quite literally, recycled galaxy. You are stardust that woke up. The Milky Way didn't just make a place for you to live, it made you, atom by atom, out of the corpses of dead stars. And here's the part that just goes to show how connected this all is. The very fact that you can sit there, look up, and wonder about the galaxy means the galaxy has produced something able to look back at itself. You're not separate from the Milky Way, observing it from outside. You're a piece of the Milky Way that became complicated enough to ask what the Milky Way is. The galaxy grew a part of itself that could turn around and study the whole. That's not poetry, that's just literally what happened. The atoms organized themselves over 13 billion years into a thing that could understand its own origins. You are how the galaxy knows itself. Now let me hit you with a few more facts about how we actually map this place, because the detective work is incredible. There's a space telescope called Gaia, launched by the European Space Agency, and its entire job has been to measure the precise positions, distances, and motions of over 1 billion stars in the Milky Way. Over 1 billion. It's been building the most detailed three-dimensional map of our galaxy ever made, charting where stars are and where they're going. And that map is how we've discovered things like the Gaia sausage, the digested remains of that ancient devoured galaxy. Gaia is basically giving us, for the first time, a real blueprint of our home, built star by star by star. We are, slowly, finally, learning the shape of the place we live, after tens of thousands of years of just guessing. And that map has revealed that the Milky Way's disk isn't even flat. We always draw it as a clean, flat pancake, but it's actually warped, bent, and flared at the edges, like a vinyl record left out in the sun, or the brim of a hat. The outer regions curve up on one side and down on the other. And astronomers think this warp might be the result of, you guessed it, past collisions and the ongoing gravitational tug of those smaller galaxies the Milky Way is in the process of eating. The galaxy isn't a tidy spiral. It's a warped, lopsided, scarred-up structure, still being deformed by its own violent feeding habits. Even its shape is a record of cannibalism. And the Milky Way has companions, satellite galaxies, smaller galaxies orbiting around it like moons around a planet. The two most famous are the Large Magellanic Cloud and the Small Magellanic Cloud, visible from the southern hemisphere as two faint smudges in the night sky. They were named after the explorer Magellan, whose crew documented them during their voyage around the world. These are dwarf galaxies, gravitationally bound to the Milky Way, slowly being pulled and stretched, and eventually they too will likely be consumed. We've found dozens of these little satellite galaxies orbiting us, faint and small and hard to detect, a whole entourage of dwarf galaxies circling our giant one, lining up to be devoured. The cannibal is always surrounded by its next meals. And zoom out even further, because the Milky Way itself isn't alone. It belongs to a group of galaxies called the Local Group, a gravitationally bound collection of dozens of galaxies, dominated by the two big spirals, us and Andromeda.
And the Local Group is part of a larger structure, and that's part of an even larger one, a supercluster called Laniakea, a name that means immense heaven in Hawaiian. The Milky Way, this enormous thing that light takes 100,000 years to cross, this thing that contains everything you've ever known, is itself just one single galaxy in a cosmic web of structure so vast that the galaxy becomes a speck, a dot, a single point of light in a network of hundreds of billions of other galaxies spread across the observable universe. You are inside a galaxy, inside a group, inside a supercluster, inside a web, and at every level the scale just gets more absurd. So here's where we are, and we've got a long way still to go through these 100 facts, but sit with what you've already got. The galaxy you pictured as your fixed, peaceful, ancient home is actually a violent, half-built, warped, scarred-up cannibal, stitched together out of the corpses of smaller galaxies it tore apart and ate, still eating, held together by an invisible substance that outweighs everything you can see and that nobody on Earth can identify, with a 4 million solar mass black hole at its heart that flings stars into exile at 1 million kilometers an hour, hurling you around it at 800,000 kilometers an hour right now, on a collision course with a galaxy bigger than itself and almost completely invisible to your eyes. And the only reason you exist to know any of this is that the whole thing built you out of the ashes of dead stars. That's the place you live. That's home. And we're just getting started. Okay, so let's keep going, because we've barely scratched the surface, and the deeper you go into this galaxy, the weirder it gets. Picture this. You're standing in a field at night, somewhere truly dark, no city glow on the horizon, and you look up. That band of light overhead, the Milky Way, looks completely still, frozen, eternal. And here's the thing your brain refuses to accept, because it's just too slow to perceive. Everything you're looking at is moving, violently. The whole sky is a churning storm in ultra-slow motion, and you're living inside a single, flickering instant of it. Let me explain. Every star you can see is on its own orbit around the galactic center, and they're all moving at different speeds in slightly different directions. The shapes of the constellations, the Big Dipper, Orion, all of them, they're not permanent. They're temporary arrangements, accidental alignments of stars that happen to be in roughly the same line of sight right now. Give it 100,000 years, and every constellation will be distorted, stretched, unrecognizable. The night sky your distant ancestors saw was subtly different from yours, and the sky your distant descendants see will be different again. The stars are drifting apart and past each other constantly. The constellations are a snapshot, not a fixture. You're looking at one frame of a movie that takes millions of years to play. And here's a specific one that gets me. The North Star, Polaris, the star that sits almost directly above the North Pole, the one that's guided navigators and travelers for centuries because it stays fixed while everything else wheels around it. It hasn't always been the North Star, and it won't always be. Because the Earth wobbles on its axis, a slow wobble that takes about 26,000 years to complete one cycle, the pole slowly points at different stars over time. Thousands of years ago, the ancient Egyptians had a different pole star, and in the future, the pole will swing around to point at other stars entirely, before eventually, tens of thousands of years from now, coming back around to Polaris. The fixed point in the sky isn't even fixed, it's just slow. Everything up there is in motion, even the thing we use to define stillness.
Now, speaking of motion, let me tell you about how fast the whole galaxy is moving. Because this is one of those facts that makes you feel like you're standing on the deck of a ship that's standing on a bigger ship that's standing on an even bigger ship. You're spinning on the Earth, which is going around the Sun, which is going around the galactic center at 800,000 kilometers an hour, like we said. But the entire Milky Way galaxy is also moving through space. The whole thing. It's being pulled toward a massive concentration of mass called the Great Attractor, and the local group of galaxies is hurtling through the universe at something like 600 kilometers per second relative to the background of the cosmos. 600 kilometers every second. You are nested inside layer after layer of motion, none of which you can feel, all of which is carrying you across distances that defy comprehension. Right now, in the time it took me to say that sentence, you moved thousands of kilometers through the universe in ways you'll never sense. Let's talk about the bulge, the central region of the galaxy, because it's a genuinely strange place. The galactic bulge is this dense, roughly spherical swarm of stars packed around the central bar and the black hole. And the stars there are crammed together far more tightly than out here in the suburbs where we live.
If you lived on a planet in the galactic bulge, your night sky would be insane. Instead of a few thousand visible stars, you might see 1,000,000 stars bright enough to be visible. A sky so crowded with light that it might never get truly dark. Imagine that. A night that's never really night because there are so many stars packed so close that they drown out the darkness. The bulge is the bright, crowded downtown of the galaxy, and we live way out in the dim, quiet countryside where you can actually see the dark between the stars. But here's the catch with that crowded center. And it's the same reason I keep telling you the suburbs win. Living in the bulge would be dangerous. With stars packed that tightly, the odds of a nearby supernova, a star exploding close enough to fry a planet's atmosphere and sterilize its surface, go way up. Nearby stars passing close could gravitationally disrupt a solar system, flinging planets out of their orbits. And you're closer to all that violent activity near the black hole. The crowded downtown might be beautiful to look at, but it's a hazardous neighborhood. Out here in the Orion Spur, far from the chaos, we've got room. We've got stability. We've had billions of years of relative peace, enough time for life to slowly figure itself out. The boring suburbs might be exactly why you exist at all. Now let me circle back to dark matter, because there's more to this mystery, and it only gets stranger the harder you look. I told you dark matter outweighs everything visible several times over, and that we can't identify it. Here's how deep the not knowing goes. We've built enormous, ultra-sensitive detectors, deep underground in old mines, shielded from all interference, specifically to try and catch a single dark matter particle interacting with normal matter. We've run these experiments for years, and so far, nothing. We have not directly detected a single particle of the stuff. We know it's there, we can map its gravity wrapping around the galaxy in a vast, invisible halo. We can see exactly how much there has to be, and yet every attempt to actually catch one and figure out what it is has come up empty. It's like knowing there's an invisible elephant in the room, because you can see the floorboards bending under its weight. But every time you reach out to touch it, your hand passes through empty air. That's the state of the art. That's how much of your galaxy remains a complete and total mystery. And it gets even weirder, because there's a second invisible mystery that's even bigger. Beyond dark matter, when astronomers look at the universe as a whole, they find that the expansion of space is accelerating, being pushed apart by something they call dark energy. Now, dark energy is more about the universe at large than the Milky Way specifically, but here's the staggering breakdown when you add it all up. Of everything in the universe, all the mass and energy that exists, the ordinary matter, the stuff that makes up stars and planets and galaxies and you, accounts for only about 5%. Dark matter is about 27%, and dark energy is the remaining roughly 68%. So the stuff we understand, the atoms, the stars, the galaxy you can sort of see, that's 5% of reality.
95% of the universe is made of things we cannot identify, cannot detect directly, and barely comprehend. You live inside a 5% universe surrounded by an overwhelming ocean of the unknown. That faint band of light you see at night is a sliver of what's actually out there. Let me bring it back to something you can grab onto, the speed of light, and what it means for looking at the galaxy, because this is where time and space get tangled in a way that's genuinely poetic. Light takes time to travel. We said the nearest star is about 4 light-years away, which means when you look at it, you're not seeing it as it is now. You're seeing light that left it 4 years ago. You're looking into the past. And this is true of everything you see in the sky. When you look at a star 1,000 light-years away, you're seeing it as it was 1,000 years ago. The light left during the early medieval period and only just now reached your eye. Look at a star 10,000 light-years away, and you're seeing light that left before human civilization began. The night sky is not a snapshot of now. It's a layered, mixed-up collage of the past, with nearby stars showing you a few years ago and distant ones showing you thousands of years ago, all at once, all jumbled together in the same view. You can't even see the galaxy as it is. You can only ever see what it was.
And here's the gut punch that follows from that. Some of the stars you can see in the night sky might already be dead. A massive star, thousands of light years away, could have exploded as a supernova centuries ago. But if it's far enough away, the light from that explosion hasn't reached us yet. So you're still seeing the steady glow it gave off before it died. You could be looking right now at a star that no longer exists, a ghost. Its light still traveling across the galaxy long after the star itself is gone. The sky is full of these possible ghosts, points of light from objects that may have already met their end. You're stargazing at a graveyard, and you can't tell which of the lights are still alive. Now let me tell you about one of the most spectacular things in the galaxy: globular clusters. These are dense, ancient balls of stars, tightly packed spheres containing hundreds of thousands, sometimes millions of stars, all bound together by gravity, all incredibly old. The Milky Way has around 150 of these globular clusters orbiting it, mostly out in the halo, the spherical region surrounding the main disk. And these clusters are among the oldest things in the entire galaxy, many of them over 12, even 13 billion years old, nearly as old as the universe itself. They're like time capsules, fossils from the earliest era of the galaxy's formation. If you lived on a planet inside a globular cluster, your sky would be unimaginable. Thousands upon thousands of brilliant stars, some of them dozens of times brighter than anything in our sky, packed so densely that the whole sky would blaze. These ancient star cities are scattered all around the Milky Way, silent relics of the dawn of time. And in the halo, that vast spherical region around the galaxy, there's something else. The oldest, most metal-poor stars. In astronomy, anything heavier than helium is loosely called a metal, even oxygen and carbon. The first stars that ever formed had almost no metals, because the heavy elements hadn't been made yet, remember. Those get forged inside stars over generations. So the oldest stars are the ones with the least heavy elements in them. Astronomers hunt for these ultra-metal-poor stars as windows into the early universe, and a few of the ones found in the Milky Way's halo are so ancient and so pure that they may be among the first generation of stars to form after the Big Bang, or close to it. These are living fossils, stars that have been quietly burning since the universe was in its infancy, still here, still shining in our galaxy right now. The Milky Way is a museum of cosmic history, and the exhibits are still glowing. Let me throw a genuinely terrifying object at you, the magnetar. We talked about neutron stars, the ultra-dense corpses of massive stars. Well, some neutron stars have magnetic fields so unbelievably powerful that they get their own category, magnetars.
The magnetic field of a magnetar is so strong that if one were positioned where the moon is, it would wipe the data off every credit card on Earth, and it would mess with the very atoms in your body. Get within 1,000 kilometers of one, and its magnetic field would literally distort the molecules you're made of, dissolving you at the atomic level. These things are real, and there are some scattered through the Milky Way.
They occasionally release bursts of energy so intense that a flare from a magnetar thousands of light years away on the other side of the galaxy has measurably affected the Earth's upper atmosphere. A burp from one of these monsters from across the galaxy reaches out and touches our planet. That's the kind of neighbor you've got out there in the dark. Now, speaking of energy bursts, let me tell you about the most powerful explosions in the universe: gamma-ray bursts. When certain extremely massive stars die, or when two neutron stars collide and merge, they can release a burst of gamma rays so intense that for a few seconds it outshines the entire rest of the universe combined. In a matter of seconds, one of these events releases more energy than our sun will produce in its entire 10 billion year lifetime. And here's the unsettling part. If a gamma ray burst went off close enough to us, within a few thousand light years, and happened to be pointed our way, it could strip away the Earth's ozone layer and trigger a mass extinction. Some scientists have even speculated that an ancient mass extinction on Earth might have been caused by exactly such an event.
So far, none have gone off close enough and aimed right at us during the time we've been around. But the galaxy is fully capable of it. The same galaxy that built you out of stardust is also armed with weapons that could erase life from your planet in seconds. It's beautiful and it's lethal, all at once. Let me dial it back to something gentler: the sun itself, because your own star has some facts worth knowing. Our sun is a yellow dwarf star, which is a slightly funny name because it's actually larger than most stars in the galaxy. Remember, most stars are little red dwarfs, so our sun is actually above average in size and brightness. It's not a giant by any means, but it's bigger and brighter than the typical galactic resident. And it's relatively young and stable, in the comfortable middle of its life, steadily fusing hydrogen into helium in its core, which it's been doing for about 4.5 billion years, and will keep doing for roughly another 5 billion. We caught our star in its calm, productive prime. Good timing on a cosmic scale. But the sun's not going to last forever, and its death is going to be a slow-motion drama. In about 5 billion years, when the sun runs low on hydrogen fuel in its core, it's going to swell up into a red giant, a bloated, cooler, enormously larger star. It'll expand so much that it'll likely swallow Mercury and Venus and possibly reach Earth's orbit, scorching our planet into a barren, lifeless rock, long before that, as the sun brightens and heats up over the coming billion years or so. Then, after the red giant phase, the sun will shed its outer layers in a gorgeous glowing shell called the planetary nebula, and what's left of the core will collapse down into a white dwarf, a dense, dim, slowly cooling ember about the size of the Earth. That's the fate of our star. Not a dramatic supernova. Our sun isn't massive enough for that, but a slow swelling, a gentle casting off, and then a long, long fade into darkness. The sun will become a cooling cinder, drifting around the galaxy for trillions of years. And here's a quietly devastating fact that comes from that. White dwarfs cool down so slowly that the universe isn't even old enough yet for any of them to have fully cooled into cold, dark balls. The very first white dwarfs ever formed are still gently glowing. The universe hasn't had time to produce a single, completely dead, cold white dwarf yet. That's how young the cosmos still is, in some sense, and how slow these stellar deaths really are. The galaxy operates on timescales that make all of human history look like a single tick of a clock.
Let me come back to the question of life, because there's a fascinating idea here called the galactic habitable zone. We talked about the habitable zone around a single star, the right distance for liquid water. But some scientists argue there's a habitable zone for the galaxy as a whole, a sweet spot in the galactic disk that's not too close to the dangerous, crowded, radiation-soaked center, but also not too far out where there aren't enough heavy elements to build rocky planets and complex life. And guess where the sun sits? Right in that comfortable middle band. Far enough from the center to avoid the supernovae and radiation and gravitational chaos. Close enough in to have plenty of the heavy elements needed to build planets and bodies. Our cosmic address might be one of the more favorable spots in the whole galaxy for life to develop.
Out of all the places you could have ended up, you landed in one of the calm, resource-rich neighborhoods. Lucky, or just the only place it could have happened? Either way, here you are. Now let me hit you with something about how the Milky Way connects to deep time on Earth, because there's a wild theory here. Remember how the sun bobs up and down through the galactic disk as it orbits, drifting in and out of the spiral arms? Some scientists have wondered whether passing through the denser spiral arms, where there's more gas, more dust, more nearby supernovae, might affect conditions on Earth, possibly even correlating with ice ages or extinction events over the vast stretches of geologic time. The idea is that our cosmic environment isn't constant, that as the solar system journeys through different regions of the galaxy over hundreds of millions of years, the conditions change, and those changes might ripple down to the climate and life of our little planet. It's not fully settled science, but the very possibility is staggering. It means the history of life on Earth might be tied, in some deep way, to where we happen to be in our lap around the galaxy.
Your planet's story and the galaxy's geography might be threads of the same fabric. Let me talk about the edge of the galaxy, the very outskirts, because even defining where the Milky Way ends is hard. The bright disk of stars fades out gradually, there's no sharp boundary, and beyond the visible disk, the dark matter halo extends much, much farther, possibly hundreds of thousands of light years out, far beyond where the stars peter out. So where does the galaxy actually end? It depends on what you count. If you count the stars, it's one size. If you count the dark matter, it's vastly larger. The Milky Way doesn't have a clean edge. It has a slow fade, a dimming, a thinning out into the dark, with the invisible halo stretching way out past where your eye, or even our telescopes, can detect anything. The galaxy is bigger than it looks, by a lot, and most of that extra size is, once again, invisible.
And out there in the far outskirts, in the halo, there are stars that don't belong to the disk at all. Halo stars on wild, plunging, elongated orbits, diving in toward the center and swinging far back out, on paths totally different from the orderly circular orbits of disk stars like our Sun. Many of these halo stars are, you guessed it, the captured remains of devoured dwarf galaxies. Stars that originally belonged to other, smaller galaxies that the Milky Way ate, now orbiting our galaxy on these strange, telltale, eccentric paths. When astronomers find a group of stars all moving together on the same weird orbit, that's often the fingerprint of an ancient meal, a stream of stars from a galaxy long since consumed. The halo is full of these refugees, and reading their orbits is like reading the dietary history of a predator. Let me tell you about the gas, because the gas in the galaxy is doing dramatic things you'd never imagine. There are clouds of gas falling into the Milky Way from outside, high-velocity clouds raining down onto the galactic disk, replenishing the supply of material for new stars. And there's gas being blown out of the galaxy too, driven by supernova explosions and the activity near the center. Launched up out of the disk in great fountains, some of it falling back down, some escaping entirely. The galaxy breathes. It takes in fresh gas from intergalactic space. It forges that gas into stars. Those stars explode and blast enriched gas back out, some of which falls back to make new stars, and some of which is lost forever. It's a vast cycle,
a galactic ecosystem with material flowing in and out and around in a churning, never-ending metabolism. The Milky Way isn't a static collection of stars, it's a living, breathing, recycling engine, and it's been running for over 13 billion years. And here's a sobering fact about that engine. It's running out of fuel. Slowly, over enormous timescales, the Milky Way is using up its gas, converting it into stars faster than it's being replenished. The rate of new star formation in our galaxy has actually declined over cosmic history. Billions of years ago, the galaxy was forming stars far more vigorously than it is today. We're past the peak. The great age of star formation is behind us.
Eventually, billions and billions of years from now, the gas will be largely exhausted and the galaxy will stop making new stars. The existing stars will live out their lives and die one by one, and no new ones will be born to replace them. The Milky Way will slowly dim, fade, redden, and go dark, over timescales so long they make the current age of the universe look like a blink. You're living during the bright, vigorous, productive era of the galaxy. The fireworks are still going, but the show, on the longest of timescales, is winding down. Let me bring it back to scale one more time, because I want you to really feel how empty the galaxy is, even though it has hundreds of billions of stars. Here's a way to picture it. If you shrank the sun down to the size of a single grain of sand, then on that same scale, the nearest other grain of sand, the nearest star, would be about 6 kilometers away. 6 kilometers. 2 grains of sand, 6 kilometers apart, with nothing but empty space in between. That's the density of stars in our part of the galaxy. The Milky Way isn't a crowded ball of stars jammed together. It's almost entirely empty space, with tiny, tiny specks of matter, separated by gulfs so vast they're almost impossible to picture. When you look at that thick band of light and think it looks dense and packed, you're being fooled by distance. Up close, it's the loneliest, emptiest place imaginable. Which, again, is exactly why galaxies can collide and pass through each other, almost without any stars touching. It's why the Andromeda collision won't be a smash-up. There's just so much room. The emptiness is the dominant feature. The stars are the exception, the rare little flecks of light in an overwhelming ocean of dark and nothing. Now let me tell you about how we figured out the shape of the spiral arms, because it's a clever bit of detective work. Since we can't get outside the galaxy to look, astronomers map the spiral arms by tracing the locations of certain markers, young bright stars, glowing clouds of ionized gas, and especially by measuring the radio emissions from clouds of cold hydrogen gas. Hydrogen, the most common element in the universe, emits a faint radio signal at a very specific wavelength, the famous 21 centimeter line. By detecting this signal from all across the galaxy and measuring how it's shifted, astronomers can map where the gas is and how it's moving, even through all the dust that blocks visible light. Radio waves punch right through the dust that hides the galactic center from our eyes. It's how we built our picture of the galaxy's structure, by listening to the radio hum of hydrogen gas spread across 100,000 light-years. We mapped our home not by seeing it, but by listening to it. And here's a name to know: Jocelyn Bell Burnell, who as a young researcher in 1967 detected the first pulsar, that precisely pulsing radio signal that was so regular it briefly got the "little green men" label. It turned out to be a spinning neutron star, and the discovery opened up an entire field of astronomy. There's some lasting controversy because the Nobel Prize for that discovery went to her supervisor and not to her. But the discovery itself stands as one of the great moments in our exploration of the galaxy. The moment we first detected these spinning stellar corpses beaming radiation across space like cosmic lighthouses. There are now thousands of known pulsars scattered through the Milky Way, each one a precise spinning clock.
some of them so reliable that scientists have proposed using arrays of them as a kind of galactic navigation and timing system, more accurate than the atomic clocks we build on Earth. Let me throw you a fact about the very fabric of space and the galaxy: gravitational waves. When extremely massive objects accelerate violently, like two black holes spiraling into each other, or two neutron stars colliding, they send ripples through the very fabric of space-time itself. Gravitational waves, stretching and squeezing space as they pass. In 2015, humanity detected these for the first time, catching the ripple from two black holes that merged over 1 billion years ago. And some of these events happen within our own galaxy and nearby. When two neutron stars in the Milky Way's neighborhood collide, they not only send out gravitational waves, they also forge heavy elements, gold, platinum, in the violent debris. That's right, much of the gold on Earth, the gold in jewelry, in electronics, possibly the gold in a ring on someone's finger, was forged in the collision of two dead stars billions of years ago. The galaxy makes precious metals in the most violent events imaginable, and then scatters them out to eventually settle into planets. Your gold is the residue of a cosmic catastrophe. Now let me come back to that central black hole one more time, because there's a feeding behavior that's genuinely wild. Astronomers have watched clouds of gas spiral in towards Sagittarius A star, and they've seen flares, sudden brightenings, as material gets superheated and torn apart just before crossing the point of no return. They've even watched a gas cloud get stretched out like spaghetti as the black hole's tidal forces pulled on it, with the near side accelerating faster than the far side. This stretching effect even has a nickname: spaghettification, and yes, that's a real term astronomers use. Anything that falls into a black hole gets stretched into a long, thin strand by the difference in gravity between its near and far sides.
If you fell into a black hole feet first, your feet would be pulled so much harder than your head that you'd be stretched into a strand of human spaghetti before you ever reached the center. It's grimly hilarious, and it's real physics, happening at the heart of our galaxy. And here's something about black holes that flips your intuition. We think of them as cosmic vacuum cleaners that suck in everything around them, but that's not quite right. A black hole only pulls things in with the same gravity that any object of that mass would have. If you replaced our sun with a black hole of exactly the same mass, the Earth wouldn't get sucked in. It would keep orbiting exactly as it does now, just in the dark and the cold. Gravity doesn't get stronger just because something is a black hole. It only gets extreme when you get very, very close to it. So Sagittarius A star isn't out there hoovering up the whole galaxy. Stars orbit it from a safe distance, stable, for billions of years, just like Earth orbits the Sun. The monster at the center is dangerous only if you get too close. From far enough away, it's just another massive thing to orbit. The galaxy isn't being eaten from the center, not yet. Let me give you a sense of just how many objects are out there beyond stars and planets. There are comets and asteroids, sure. But on the galactic scale, there are also rogue planets, worlds with no star at all, kicked out of their birth systems, wandering alone through the dark between the stars. There might be billions of these, possibly even more rogue planets than there are stars in the galaxy. Lonely, dark, frozen worlds, drifting forever through interstellar space with no sun to warm them, no star to orbit, just endless night. Some scientists have even speculated that some of these rogue worlds might, in theory, retain enough internal heat to harbor liquid water deep beneath frozen surfaces. Life in total darkness, far from any star, drifting through the void. We don't know if it exists, but the galaxy is vast enough and strange enough that you can't rule it out. And there are brown dwarfs, objects that are bigger than planets, but not quite massive enough to ignite as true stars. Failed stars, you might call them. They glow dimly with leftover heat, but never manage to start the full nuclear fusion that powers a real star.
The galaxy is full of these in-between objects, neither star nor planet, occupying a strange middle ground,
dim and hard to detect, drifting through the dark. The more we look, the more we find that the galaxy isn't neatly divided into stars and planets. It's a continuum, a spectrum of objects of all sizes, most of them dim, most of them hidden, most of them things you'll never see. Let me bring up something that connects all the way back to the beginning, the cosmic microwave background. This is the faint afterglow of the Big Bang itself, radiation left over from when the universe was just a few 100,000 years old, now stretched out and cooled into faint microwaves filling all of space. It's everywhere, coming from every direction, the oldest light in existence. And here's the thing, it's passing through the Milky Way and through you right now. A tiny fraction of the static on an old, untuned television set was actually this primordial radiation, the echo of the birth of the universe, picked up by the antenna. The beginning of everything is still detectable, still washing over your galaxy, still faintly glowing in the background of all things.
The Milky Way is swimming in the afterglow of creation, and so are you.
Now, let me come back to the human scale, because after all this cosmic immensity, there's something worth sitting with. Everything we've talked about, the black hole, the dark matter, the devoured galaxies, the spiral arms, the dying stars, all of it we figured out from one tiny planet, orbiting one ordinary star, way out in a minor spur of one galaxy among hundreds of billions. We never left. We've sent a handful of robotic probes to the edge of our own solar system, and that's it. The farthest human-made object, the Voyager 1 spacecraft, launched in 1977, has traveled for decades and only just crossed out of the sun's bubble of influence into interstellar space. And at its speed, it would take tens of thousands of years to reach even the nearest star, which it isn't even headed toward. We have not gone anywhere, galactically speaking. We're still standing in our own driveway.
And yet, from that driveway, using telescopes and physics and mathematics and stubborn curiosity, we've mapped a structure 100,000 light-years across, weighed an invisible substance we can't even detect, dated stars older than the galaxy, and predicted a collision 4 billion years in the future. That's the most astonishing fact of all, maybe. Not what's out there, but that a species stuck on one rock figured so much of it out without ever leaving home. And Voyager carries something with it, the Golden Record, a phonograph record plated in gold, carrying sounds and images of Earth, greetings in dozens of languages, music, the sound of a heartbeat, a kiss, whale song, all of it meant as a message to any intelligence that might one day find it drifting through the galaxy. It's a message in a bottle, tossed into the cosmic ocean, almost certainly never to be found, but launched anyway, out of hope, out of the sheer human need to say, we were here, we existed, we looked up, and we wondered. That little gold disc is humanity's introduction to the Milky Way, drifting silently through the dark, carrying the sound of who we are out into a galaxy that may never notice. And whether or not anyone ever finds it, the gesture itself is one of the most beautiful things our species has ever done. Let me circle back to the constellations and the deep past, because there's a beautiful connection to how humans have always related to this galaxy. Every culture on Earth, going back tens of thousands of years, looked up at that band of light and told stories about it. To some, it was a river in the sky. To some, it was a road traveled by the dead, a path of souls. To some, it was milk spilled across the heavens by a goddess. The Milky Way is woven into the mythology of nearly every human civilization that ever existed, because for almost all of human history, it was just there, every clear night, the brightest, most striking feature of the dark sky, impossible to ignore. It shaped our religions, our calendars, our navigation, our sense of our place in the cosmos. And now, in the span of just a century or so, we've lit up our cities and erased it from view for most of humanity. We're the first generations in the entire history of our species to largely lose sight of the galaxy that defined the night for every ancestor who came before us. That's a strange and a little bit sad thing to be the first at. And here's the thought to leave this chunk on, because it ties so much of this together. Everything we've been talking about,
the violence, the cannibalism, the dark matter, the black hole, the dying and being born of stars, all of it has been going on for over 13 billion years, almost entirely without witness. For more than 13 billion years, the Milky Way devoured galaxies, forged elements, birthed and killed stars, spun and warped and breathed, and there was, as far as we know, nobody to see any of it. And then, on one small planet, after billions of years, atoms arranged themselves into eyes and brains and curiosity. And for the first time, the galaxy had something inside it that could look around and understand what it was looking at. You are part of that incredibly recent, incredibly rare moment. The moment the galaxy opened its eyes. Out of 13 billion years of unwitnessed grandeur, you happen to be alive during the eye blink when it could finally be seen. And you can see almost none of it.
But the part you can see, and the much larger part you can now understand, that's enough to know you're living inside something far stranger and more violent and more beautiful than the calm band of light you thought it was. And we're only halfway through. Okay, so let's pick up right where we left off, because if you think the galaxy has shown you all its weirdness, you've seen nothing yet. Picture this. You're floating in deep space, somewhere out in the halo of the Milky Way, looking back at the whole thing spread out below you like a glowing pinwheel. And you notice something strange. The disk, the bright flat part where all the action is, where the sun lives, where the spiral arms swirl, that's actually incredibly thin, like absurdly thin. Let me explain. The Milky Way's main disk is about 100,000 light-years across, but it's only about 1,000 light-years thick. Do the math on that ratio. It's like a stack of, what, 100 to 1? The galaxy is proportionally far flatter than a vinyl record, flatter than a sheet of paper, flatter than almost anything you can hold in your hand. If you scaled the Milky Way down to the width of a dinner plate, it would be thinner than the plate itself, thinner than a credit card laid flat. That's the structure you live in. A vast, razor-thin sheet of stars, spinning, with you embedded near the middle of its thickness, out in the suburbs. The reason that band of light looks like a band, a stripe across the sky, is precisely because the galaxy is so flat. You're looking edge-on through the thin pancake, the long way, so all the light piles up in a line. Look perpendicular to the disk, up out of the pancake, and the stars thin out fast, because there's barely any galaxy in that direction. And here's a fun consequence of living in a flat disk. The sun doesn't just go around the galactic center in a perfect flat circle. It bobs. As it orbits, it oscillates up and down through the plane of the disk, like a horse on a carousel that also goes up and down, crossing through the midplane of the galaxy, drifting up above it, falling back down, crossing through again. Right now, the sun is actually slightly above the central plane of the galaxy and drifting upward. We complete one of these up and down bobs every 60 to 70 million years or so, multiple times per galactic orbit. So your true path through the galaxy isn't just a spiral, it's a spiral with a wave riding on top of it, weaving up and down through the thin disk as it loops around the center. Nothing about your motion through space is simple. It's a corkscrew with a wobble. Now let me tell you about a discovery that genuinely rewrote part of the textbook, and it has to do with that warp I mentioned earlier. For a long time, we drew the galaxy as a flat disk. Then we learned it was warped at the edges, bent up on one side and down on the other. But more recently, using that incredible Gaia map of over 1 billion stars, astronomers found that the warp isn't even static, it's moving. The warp itself precesses. It wobbles around the galaxy over time, like the wobble of a spinning top that's starting to tip. The outer disk of the Milky Way is flapping, slowly, majestically, over hundreds of millions of years. And the best explanation, again, is the gravitational influence of those satellite galaxies and the lingering effects of past collisions tugging on the disk. The galaxy isn't a rigid object, it's flexible,
It ripples, it flaps at the edges like a flag in a slow cosmic wind. Even the shape you thought was fixed is actually in slow, constant motion. And here's another ripple, literally. Astronomers have found that the disk of the Milky Way has waves running through it, vertical ripples where stars are bunched slightly above and below the midplane in a wave pattern, like ripples spreading across the surface of a pond. And what caused these ripples? The leading idea is that a smaller galaxy, possibly the Sagittarius dwarf, that very galaxy we're shredding right now, plunged through the disk of the Milky Way in the past, like a stone dropped into water, and sent these ripples spreading outward. We can still see the waves. The galaxy is still ringing from the impact of a collision that happened long ago. Our galactic home is, quite literally, still vibrating from being hit. Read that again. The disk you live in is shuddering from a cosmic collision, and the ripples are still spreading. You're standing on a galaxy that's still ringing like a struck bell. Let me bring up the Sagittarius dwarf one more time, because its story is so dramatic.
This little galaxy has actually passed through the disk of the Milky Way multiple times over billions of years, each pass tearing it apart a little more. Each pass possibly triggering bursts of new star formation in our galaxy as the gravitational disturbance compressed clouds of gas. And here's the wild part. Some scientists have proposed that one of these passes, the gravitational shockwave from the Sagittarius dwarf plunging through our disk, may have triggered the very burst of star formation that created our Sun about 4.5 billion years ago. Think about that. The collision with a smaller galaxy might be the reason the Sun exists, which means it might be the reason you exist. The cannibalism that builds the galaxy might also be what sparked your own star into being. The same violence that's tearing that little galaxy apart right now might have, billions of years ago, lit the match that became your home. That's not poetry. That's a real scientific hypothesis. You might be a child of a galactic collision.
Now let me hit you with something about the future, the very far future. Because we talked about the Andromeda collision in 4 billion years, but the story doesn't end there. After the Milky Way and Andromeda merge into that combined galaxy people call Milkomeda, the spiral structure will be destroyed. When two big spirals collide and merge, you don't get a bigger spiral, you get an elliptical galaxy, a big, smooth, featureless blob of stars, with no spiral arms, no clean disk, just a swarm of stars buzzing around on random orbits. So the beautiful spiral pinwheel of the Milky Way is temporary. In a few billion years, it'll be churned and scrambled into a shapeless elliptical cloud. The gorgeous structure we live in, the arms, the disk, the whole elegant form, it's a phase, not a permanent state. The galaxy will lose its shape entirely, and what's left will be a dim, reddish, slowly fading ball of aging stars. Everything beautiful about the galaxy's form is on the clock. And here's the loneliest fact in the whole set, and it has to do with the expansion of the universe.
Because of dark energy, that mysterious force we mentioned that's accelerating the expansion of space, the universe is spreading apart faster and faster. And over enormous timescales, this means that distant galaxies are being carried away from us faster and faster, until eventually they'll be receding faster than their light can ever reach us. Which means, in the far, far future, hundreds of billions of years from now, an observer in our merged Milkomeda galaxy will look out into the night and see nothing. No other galaxies. They'll all have vanished beyond the cosmic horizon, carried away by the expansion of space, their light forever unable to reach our corner of the universe. The night sky of the far future will contain only the stars of our own galaxy, and beyond them, perfect, total, empty blackness. Any astronomers alive then would have no way of even knowing that other galaxies ever existed, no way to discover the expanding universe, no way to find the evidence of the Big Bang, because it'll all be gone, swept beyond view.
We are living in a privileged moment when the universe is still young enough that we can see the other galaxies and read the history of the cosmos in their light. Future civilizations won't have that. The evidence is expiring. We're living during the readable era of the universe, and it's a fleeting one. Let me bring it back to the present and to something you can actually go out and find, the Andromeda Galaxy itself. Because here's a fact that should blow your mind. Andromeda is the most distant object you can see with your naked eye. On a clear, dark night, in the right direction, you can spot a faint, fuzzy patch of light. And that fuzzy patch is an entire other galaxy, 2.5 million light-years away, containing something like 1 trillion stars. When you look at it, the light hitting your eye left Andromeda 2.5 million years ago, before modern humans even existed, back when our ancestors were early hominids walking the African savanna. That ancient light, after a journey of 2.5 million years across the void between galaxies, ends its trip by landing on your retina. You, standing in a field, can catch photons that have been traveling since before your species existed, from an island of 1 trillion stars with nothing but your own 2 eyes. And most people have no idea they can do this. They walk right past the chance to see another galaxy. Now let me get into something genuinely strange about the center of the galaxy, those young stars that shouldn't be there. Right near the supermassive black hole, astronomers have found young, massive, bright stars orbiting close in. And this is a puzzle, because the region right around a black hole should be a terrible place to form stars. The intense gravity, the tidal forces, the radiation, all of it should rip apart any cloud of gas trying to collapse into a star long before a star could form. The gas should be shredded, not condensed. And yet, there are young stars there. Astronomers call this the paradox of youth. How did young stars form in a place where star formation should be impossible? There are theories. Maybe the gas was dense enough to resist the tidal forces. Maybe the stars formed elsewhere and migrated in. But it's still not fully settled.
The neighborhood of the black hole has stars that, by all rights, shouldn't exist there.
The galaxy keeps doing things it's not supposed to be able to do. And here's another thing near the center, a swarm of stellar mass black holes. We've got the one supermassive black hole at the very center, but astronomers think there should be thousands of smaller, stellar mass black holes, the corpses of dead massive stars, clustered in the dense central region, sinking toward the center over time. So the heart of the galaxy isn't just one black hole. It's potentially a whole nest of them, a swarm of dark, dead stars gathered in the crowded core, occasionally interacting, occasionally merging, occasionally flinging things around. The center of the Milky Way might be one of the most black hole-dense places in the entire galaxy, a graveyard of collapsed stars packed around the supermassive monster. Not a place you'd ever want to visit. Let me talk about something we can actually measure with shocking precision: the speed and distance of the galactic center. For a long time, the exact distance from the Sun to the center of the galaxy was uncertain, give or take a few thousand light-years.
But by tracking the orbits of those stars whipping around Sagittarius A star, and using a technique that's almost like cosmic surveying, astronomers have now pinned it down to remarkable accuracy, about 26,000 light-years, give or take just a little. We've measured the distance to the heart of our galaxy, a place hidden behind impenetrable dust, by watching stars dance around an invisible black hole. And we've gotten it accurate to within a small margin. That's an astonishing feat of precision for something you literally cannot see directly. We've surveyed our own galaxy's heart through a veil of dust, using the gravity of a void. Now let me come back to the building blocks, the chemistry of the galaxy, because there's something deeply important here about generations of stars. The very first stars, the ones that formed from pure hydrogen and helium with no heavier elements, were probably enormous, far more massive than stars today, and they burned hot and fast and died young, exploding and seeding the universe with the first heavy elements. We call them population 3 stars, and here's the haunting thing: we've never actually seen one.
Not a single confirmed observation. They lived and died so early in the universe, so long ago, and they're so distant that we've never directly detected one. They're theoretical, inferred, necessary, but unseen. The very first generation of stars, the ones that started the whole chain of chemical enrichment that eventually led to planets and to you, remains a kind of ghost, a vital chapter in the story that we know must have happened, but have never witnessed. Astronomers are searching for them with the most powerful telescopes ever built, hoping to catch the light of the very first stars before they vanish beyond reach. The origin of all the heavy elements in your body traces back to a generation of stars no one has ever seen. And then there were the second generation, population 2 stars, the old metal-poor stars in the halo and the globular clusters, formed from gas that had a little bit of heavy elements from those first stars. And then our generation, population 1 stars, like the Sun, formed from gas richly seasoned with the heavy elements from many previous generations of stellar death. So the Sun is a third generation star, or later. It was built from the recycled ashes of countless earlier stars that lived and died and enriched the gas before our star ever formed. Every generation of stars cooks up more heavy elements and passes them on, like a relay race spanning billions of years. And the Sun and you are the inheritors of all those previous runners. You're standing on the shoulders of generations of dead stars, each one a little richer in the elements of life than the last. Let me throw you a number that captures how productive and how vast this all is. Over its entire lifetime, the Milky Way has produced and continues to host stars at an astonishing rate. And across all that time, the total number of stars that have ever lived and died in our galaxy is staggeringly larger than the 100 to 400 billion currently shining. Countless stars have already burned out, leaving behind white dwarfs, neutron stars, and black holes. The galaxy is full of dead stars, the corpses outnumbering eventually the living. As the eons pass, more and more of the galaxy will be these stellar remnants, dim cinders and dark holes, with fewer and fewer bright living stars among them.
The Milky Way is slowly transitioning from a galaxy of the living to a galaxy of the dead, over timescales so long that the entire current age of the universe is just the bright opening act. Now let me bring up something practical and mind-bending at once. How we even know how fast the galaxy is rotating, and how that revealed dark matter in the first place. The person whose work was central to this was Vera Rubin, an astronomer who in the 1970s carefully measured the rotation speeds of stars and gas in galaxies, including detailed studies that built the case. She and her colleagues found, over and over, that the outer parts of galaxies rotated far too fast for the visible mass to hold them together. This is the rotation curve problem, and it was Vera Rubin's meticulous observations that turned dark matter from a fringe idea into something the scientific community had to take seriously. She measured the impossible speeds again and again until the conclusion was unavoidable. There must be vast amounts of unseen mass. She didn't get a Nobel Prize, which many consider a significant oversight, but her work fundamentally changed our understanding of what the universe is made of. One careful observer, patiently measuring how fast stars spin, uncovered the fact that most of the matter in the cosmos is invisible. That's the power of paying close attention. Let me give you a sense of the timescales for the death of the galaxy, because they're almost impossible to write down. The last stars to burn out will be those tiny red dwarfs, the most common stars, which burn so slowly they can last for trillions of years, maybe up to 100 trillion years. 100 trillion. The universe is currently less than 14 billion years old. So the era of star formation and burning stars, the bright era we live in, will continue for thousands of times longer than the universe has existed so far.
And then, after that, comes the long, long dark, an era of black holes and cold, dead remnants and almost no light, stretching on for timescales with so many zeros that the numbers stop meaning anything.
The bright, star-filled chapter of the universe, the one you're living in, is actually a tiny sliver at the very beginning of a story that's almost entirely darkness. You exist during the dawn. Cherish the light. And here's a beautiful inversion of that gloom. Because the universe is so young right now, in the grand scheme, we are among the very first observers possible. Complex life requires heavy elements, which took generations of stars to build up. The universe had to age, had to enrich itself, before planets like Earth and beings like you could even form. We couldn't have existed in the early universe. There weren't enough heavy elements yet. So we're not late to the party, we're early. We're some of the first guests to arrive, in a universe that's still young and bright and full of visible galaxies, while the evidence of the cosmos's history is still readable in the sky. There's something profound about that. You're not a latecomer in an old universe, you're a pioneer in a young one. The galaxy and the cosmos are still in their bright youth, and you get to witness it before the long fade begins. Now let me come back down to Earth, literally, and talk about how the galaxy affects us in ways you'd never think of.
Cosmic rays. These are high-energy particles, mostly protons, zipping through the galaxy at nearly the speed of light, flung out by supernovae and other violent events. They're raining down on you right now, constantly, passing through your body, through the ground, through everything. Most are deflected by Earth's magnetic field and atmosphere, which is a good thing because they're a form of radiation. The galaxy is filled with this invisible storm of high-energy particles, and our planet's magnetic field is a shield that protects the life on its surface from the worst of it. Step outside that protection, into deep space, and the cosmic radiation becomes a serious hazard, one of the biggest dangers for any future astronauts trying to travel between the planets, let alone the stars. The galaxy is not a gentle place. It's bathed in radiation, and we survive only because Earth wraps us in protective shields of magnetism and air. And those cosmic rays do something fascinating when they hit the atmosphere.
They create showers of secondary particles, and some of these interactions produce carbon-14, a radioactive form of carbon in the upper atmosphere. That carbon-14 gets incorporated into living things, and because it decays at a known rate, it's the basis of radiocarbon dating, the technique archaeologists use to date ancient artifacts and remains. So the galaxy's cosmic rays, those high-energy particles from exploding stars, are literally the reason we can date the bones of ancient humans and the wood of ancient civilizations. The violence of the galaxy left a clock ticking inside every living thing. The stars don't just build you, they timestamp you. Let me tell you about a curious feature of the galaxy's magnetic field, because yes, the whole galaxy has a magnetic field, woven through the gas and dust, threading across thousands of light years. It's faint, far weaker than the magnetic field of a refrigerator magnet, but it stretches across unimaginable distances, and it shapes how the gas flows, how cosmic rays travel, how the spiral arms hold their form.
The galaxy is laced with invisible magnetic field lines, an enormous, ghostly, structuring force that we can map by studying how it twists the light from distant stars and aligns the dust grains in space. It's yet another invisible architecture, another hidden layer of the galaxy that your eyes can't see, but that helps hold the whole thing together and guide its flows. The Milky Way is wrapped in magnetism the way it's wrapped in dark matter, both invisible, both essential, both quietly running the show. Now here's a fact that connects the galaxy to the very air you breathe, in a roundabout way. The oxygen in Earth's atmosphere, the oxygen keeping you alive, was forged in stars and scattered by their deaths, just like the atoms in your body. But here's the layered part. The Earth itself, the whole planet, formed from a disk of gas and dust around the young sun, and that gas and dust was enriched with heavy elements from generations of dead stars in this region of the galaxy.
So the iron in Earth's core, the silicon in its rocks, the gold in its crust, the carbon in all life, all of it came from stellar death, gathered together in this particular spot in the Milky Way about 4.5 billion years ago. Your entire planet is a condensation of galactic ashes, a clump of stardust that gravity pulled together into a world. And then, on the thin skin of that clump, life arose, and eventually, you. The ground under your feet is dead star. The planet is a tombstone that became a cradle. Let me bring up a strange and humbling idea. The possibility that there's a hidden population of objects we've barely glimpsed, including the chance of more black holes drifting through the galaxy than we know. Stellar mass black holes, the corpses of dead, massive stars, are extremely hard to detect when they're alone, not feeding, not pulling gas off a companion star. A lone black hole drifting through space gives off no light, makes no sound, sends out no obvious signal. We can sometimes catch them when they pass in front of a distant star and bend its light, a technique called gravitational microlensing, but mostly they're invisible. There could be tens of millions, maybe 100 million of these dark, silent black holes wandering the Milky Way, and we'd have almost no way of knowing they were there. One could be drifting through interstellar space relatively nearby, and we'd never see it coming. The galaxy is full of these invisible dark stars, lurking, undetectable, the ultimate hidden objects. Add them to the list of things you live among, but cannot see. Now let me talk about a recent and genuinely exciting development, the discovery of what might be the closest black holes to Earth. Using that Gaia data again, astronomers spotted stars that were orbiting something invisible, something massive with no light coming from it, the telltale sign of a black hole companion. A couple of these have been found within a few thousand light-years of us, the closest known black holes to our solar system. They're not a threat, they're far too distant to affect us, but their discovery shows how much is still hidden in our own galactic neighborhood. We're only just now developing the tools to find these dark companions, and as we get better at it, we're going to find that the galaxy around us is far more populated with black holes and dead stars than we ever realized. The dark is filling in. The map is getting darker, in a sense, as we discover all the things in it that give off no light. Let me bring up the idea of galactic archaeology, because it's such a beautiful concept. By studying the ages, compositions, and motions of stars, astronomers can reconstruct the history of the galaxy, like archaeologists digging through layers of sediment to reconstruct the past, except the layers here are written in the chemistry and orbits of stars. The oldest, most metal-poor stars on plunging orbits tell us about the early, chaotic formation of the galaxy and the smaller galaxies it ate. The younger, metal-rich stars on circular orbits in the disk tell us about the later, calmer era. Streams of stars all moving together tell us about specific galaxies that were devoured and when. By reading the stars like layers of rock, astronomers have pieced together a timeline of mergers, collisions, and growth spanning over 13 billion years. The galaxy keeps its own diary, written in the stars, and we're slowly learning to read it. Every star is a page, every stream is a chapter, and the story they tell is one of relentless, ongoing cannibalism and growth. And here's one of the most dramatic chapters that galactic archaeology uncovered, the discovery that the Milky Way actually has two distinct disks, a thin disk and a thick disk. The thin disk is where the Sun lives, full of younger stars on nice, orderly orbits. But surrounding it is a thicker disk of older stars, puffed up on more disturbed orbits. And the best explanation for that thick disk is, you guessed it, ancient violence. Long ago, a collision or merger, possibly that Gaia sausage galaxy we talked about, stirred up the early disk of the Milky Way, puffing it up, heating its orbits, creating that thick layer of older stars. So even the layered structure of the galaxy's disk is a record of a past collision.
The thick disk is a scar, a frozen memory of an ancient cosmic wreck, preserved in the orbits of stars that have been circling for billions of years since the impact. Everywhere you look in this galaxy, you find evidence of the violence that built it.
Let me come back to the human story one more time before we close this chunk, because there's something worth dwelling on. We've talked about how little of the galaxy you can see, 0.00003% with the naked eye. But think about how that number has changed, not because the galaxy changed, but because we built better eyes. The naked eye sees a few thousand stars. A small telescope reveals millions. The great observatories on mountaintops and in space reveal billions, along with the gas, the dust, the structure, the black hole, the streams of devoured galaxies. We can't change how much light reaches us, but we built machines to gather more of it, to see in wavelengths our eyes can't, infrared to pierce the dust, radio to map the hydrogen, X-rays to spot the hot, violent regions, gamma rays to catch the most energetic events. Each new kind of eye revealed a galaxy our ancestors couldn't have imagined. The Milky Way didn't get bigger or stranger. We just got better at seeing what was always there. And we're not done. Every new telescope reveals more.
The galaxy you can perceive today is vastly larger than the one anyone could perceive a century ago. And the one your descendants will perceive will be larger still. And here's a final thought to sit with as we close this chunk. Every single fact we've covered, the cannibalism, the dark matter, the black hole, the thin disk and thick disk, the ripples, the warp, the devoured galaxies, the dying stars, the rogue planets, the invisible magnetic fields, all of it has been true for billions of years, whether anyone knew it or not. The galaxy was a violent, half-built, cannibal structure held together by invisible matter long before there were eyes to see it or minds to understand it. The truth was always there. What's new, what's astonishingly, breathtakingly new in just the last century or so, is that a part of the galaxy finally woke up enough to figure it out. You're living at the very beginning of understanding. We've gone from thinking the Milky Way was a band of spilled milk to mapping its dark matter halo and predicting its collision with Andromeda in the span of a few human lifetimes.
The galaxy has been keeping its secrets for 13 billion years, and we've only just started prying them loose. And the strangest, most wonderful part is that we're doing it from a single small planet, orbiting an ordinary star, way out in a minor spur, with nothing but borrowed starlight and stubborn curiosity. We've got more to cover, more secrets, more violence, more beauty hiding in that thin band of light overhead. So stay with me, because the last stretch of this is where it all comes together. Okay, so we're in the home stretch now, and I want to take you somewhere first. Picture this. The year is, let's say, 4 billion years from now. You're standing on what's left of Earth, or imagine you are, looking up, and the entire sky is dominated by an enormous, glowing spiral, Andromeda, so close now that it fills the heavens, brighter than anything, its arms stretched and warped as it begins to tangle with our own galaxy. That's the future night sky, and here's the thing. Almost none of the individual stars will collide, we covered that, but the gas clouds will. When the gas of two galaxies slams together, it gets compressed, and compressed gas collapses into stars. So the collision will trigger an enormous burst of new star formation, a firestorm of stellar birth, lighting up the merging galaxies in brilliant blue young stars. The death of the Milky Way as we know it will also be one of the most spectacular baby booms of stars in its entire history. Destruction and creation, the same event. That's the galaxy in a nutshell, and let me explain how that pattern runs through everything. Because here's a fact that captures the whole strange paradox of this place. Star formation needs cold gas, and collisions provide it by compressing clouds.
But collisions also can blast gas out of a galaxy entirely, and the burst of new stars uses up the remaining fuel fast. So a galaxy merger is both a burst of birth and the beginning of the end. After Milkomeda has its great baby boom, the gas will largely be spent, and the combined galaxy will slowly settle into being a quiet, reddish elliptical, making fewer and fewer new stars, fading over the eons. The fireworks finale is also the last act. The galaxy goes out, not with a whimper, but with one final brilliant blaze of creation, and then the long quiet.
There's something almost beautiful about that the end is also the brightest moment.
Now let me bring up a few more of the genuinely bizarre residents of the Milky Way, because we're not done with the weirdness. There are stars that pulse, variable stars that brighten and dim in regular cycles. One particular type, called Cepheid variables, pulse with a rhythm directly tied to their true brightness. The longer the pulse, the brighter the star. And this turned out to be one of the most important discoveries in all of astronomy, because it gave us a cosmic measuring stick. If you know a star's true brightness, and you measure how bright it appears, you can calculate exactly how far away it is. This was figured out by Henrietta Swan Leavitt in the early 1900s, and it's how we first measured the true scale of the galaxy and the universe. It's how we learned that Andromeda was a separate galaxy and not just a cloud within our own. These pulsing stars, scattered through the Milky Way, are the rulers we use to measure the cosmos. The galaxy gave us the tools to measure the galaxy. You just had to know how to read the rhythm of a flickering star.
And here's a humbling bit of history that goes with that. For most of human history, people thought the Milky Way was the entire universe. That was it. Those fuzzy patches in the sky, like Andromeda, were assumed to be clouds within our own galaxy. It was only about a century ago, in the 1920s, that astronomers, using those Cepheid variables, proved that Andromeda was actually a whole separate galaxy, impossibly far away, an entire other island universe of billions of stars. In an instant, the universe got unimaginably bigger. We went from thinking the Milky Way was everything to realizing it was one galaxy among what we now know are hundreds of billions, maybe 2 trillion galaxies in the observable universe. That's a shift in perspective that happened within living memory of some people's grandparents. The realization that we are not the whole universe, just one small part of it, is shockingly recent. Your great-grandparents may have grown up believing the Milky Way was all there was. Let me give you a sense of just how many galaxies we're talking about, because it ties back to your own insignificance and significance at once. The observable universe contains somewhere around 2 trillion galaxies. 2 trillion. And the Milky Way, this thing we've spent all this time exploring, this thing so vast that light takes 100,000 years to cross it, this thing with hundreds of billions of stars and trillions of planets, is just one of those 2 trillion galaxies. If each galaxy were a single grain of sand, you'd have enough sand to fill, well, an unimaginable amount. And you live on one planet, orbiting one star in one minor spur of one of those 2 trillion galaxies. The scale is so far beyond human comprehension that the only honest response is a kind of stunned silence. And yet, here's the flip side. That one tiny being, you, on that one tiny planet, has managed to figure out that there are 2 trillion galaxies. The smallness and the greatness live in the same breath. Now let me come back to the Milky Way specifically and talk about its name in different terms, because there's something poetic in how universal it is. Almost every culture independently noticed that band of light and gave it a name tied to milk, or a path, or a river. The very word galaxy comes from the Greek word for milk, galaxias. So when we use the word galaxy today to describe any of those 2 trillion star islands, we're using a word that originally just meant the milky band in our own sky. The whole concept of a galaxy, applied to the entire universe, is named after the spilled milk appearance of our home. We named the universal after the local, the way a child might call all big cats by the name of the one in their backyard. There's something deeply human in that,
naming the cosmos after the only piece of it we could see. Let me tell you about the thing that's going to outlast almost everything, the degenerate remnants. After all the stars have died, what's left of the galaxy will be white dwarfs slowly cooling toward black, neutron stars spinning down, and black holes. And of those, the black holes will last the longest by far. Over timescales so vast they're almost meaningless, even black holes are thought to very slowly evaporate, leaking away their mass as faint radiation over a process that takes unimaginable amounts of time, far, far longer than the current age of the universe. Numbers with so many zeros they break your brain.
The supermassive black hole at the center of the Milky Way, 4 million times the mass of the Sun, will be one of the last structures standing, long after every star has died and the galaxy has dispersed. In the deep, deep future, that central black hole will be a lonely monument, the last remnant of a galaxy that once blazed with hundreds of billions of stars. And eventually, even it will fade. The galaxy ends, finally, in total darkness and emptiness. But that's so far away that the entire current age of the universe is, by comparison, less than the first instant of a long, long night. Okay, that's heavy. Let me bring it back to something hopeful and close to home. Because for all this talk of endings, you're living in the bright, vibrant, ongoing middle of the story. Right now, somewhere in the Milky Way, new stars are igniting in glowing nebulae. Right now, planets are forming around young suns. Right now, the galaxy is rich with gas, blazing with stars, full of possibility. The Sun has another 5 billion years of stable burning ahead of it. Earth has been habitable for billions of years and could remain so for a good while yet.
You are not living in the twilight of the galaxy. You are living in its golden afternoon, with the warm light still streaming and plenty of day left. The endings we've talked about are real, but they are unfathomably far away. Your moment is one of light and abundance, even if you're standing in a quiet corner of it. Let me give you one more set of facts about the sheer richness of what's out there, the variety of worlds. We found planets orbiting 2 stars at once, like the fictional one with the double sunset, except real. We found planets so dense they're thought to be mostly metal, the stripped cores of worlds that lost their outer layers. We found puffy planets less dense than cotton candy, so light they could almost float on water if you had an ocean big enough. We found planets where one side faces their star forever in eternal day, while the other side is locked in eternal frozen night, with winds screaming around the boundary. We found a planet where it likely rains liquid rock, and others wrapped in clouds of vaporized metal. The galaxy is a laboratory of worlds, running every conceivable experiment in planet building, and we've only sampled the tiniest fraction of the planets within a few thousand light years. Beyond that, across the full 100,000 light years of the galaxy, there are trillions more worlds, almost all of them forever beyond our ability to study, each one as real and as detailed as Earth, with its own landscapes, its own weather, its own silent story unfolding with no one to witness it. And among all those worlds, the question that never goes away, is any of it alive? We've talked about the Great Silence, the fact that we found no signs of other civilizations yet. But the search continues. We're scanning the skies for radio signals. We're analyzing the atmospheres of distant planets for chemical signs of life. We're looking for anything, a whisper, a hint, that we're not alone in this galaxy of trillions of worlds. So far, nothing definitive. But the galaxy is enormous, and we've barely begun to look, and the absence of evidence so far is not the same as evidence of absence. The most honest thing anyone can say is, we don't know. We might be alone, the only minds in the entire Milky Way,
which is a staggering and lonely thought. Or the galaxy might be quietly teeming with life we just haven't found yet, which is equally staggering. Either answer changes everything. And we're the first generation with even the tools to seriously ask the question. That's the era you're living in, the era when humanity first began, seriously, scientifically, to ask whether we're alone in the galaxy. Let me bring up something I find genuinely moving about our place in time. We figured out the age of the galaxy, 13.6 billion years. We figured out the age of the universe, 13.8 billion years. We figured out that we're made of stardust, that the galaxy is a cannibal, that it's held together by invisible matter, that it's on a collision course with Andromeda. And we figured all of this out in a tiny window of time, a few centuries of real science, a few decades of really good telescopes. For 13 billion years, the galaxy spun on with no one to understand it. And then, in a flash, in the blink of a cosmic eye, a species on one small planet pieced together its entire story.
We arrived late enough that the universe had built us out of the elements of dead stars, and early enough that the evidence of the cosmos's history was still readable in the sky. That window, the window where understanding is possible, is precious and probably temporary. We happen to be alive inside it. That's not nothing. That's maybe the most remarkable coincidence of all. Now let me tie the biggest threads together, because we've covered 100 facts and more, and I want you to walk away feeling the whole shape of it. You started this thinking the Milky Way was your calm, fixed, peaceful home, a pretty band of light in the sky. And here's what it actually is. It's a violent, half-built thing, stitched together over 13 billion years from the wreckage of smaller galaxies it tore apart and devoured. Still eating one right now, the Sagittarius dwarf, still ringing from past collisions, its disk rippling and its edges warping from the violence. It's held together by dark matter, an invisible substance that outweighs everything you can see 5 to 10 times over, that we've named but cannot identify, that we've tried and failed for decades to catch even a single particle of.
At its heart sits a black hole 4 million times the mass of the Sun, crammed into a space smaller than Mercury's orbit, that flings stars out of the galaxy at over 1 million kilometers an hour. It contains stars older than itself, born before it existed. It hurls you around its center at 800,000 kilometers an hour, in a corkscrew with a wobble, and you've only completed about 20 laps in the Sun's entire 4.5 billion year life. In 4 billion years, it'll collide with Andromeda, and the two will merge, with almost no stars touching, into one larger galaxy that loses its spiral shape forever. And you can see almost none of it, 0.00003% with the naked eye. And the third of humanity can't see even that because of the lights we've switched on. And the deepest fact of all, the one that ties you to all of it, every atom in your body was forged inside a star, scattered across the galaxy by that star's death, and gathered up over billions of years into you.
The iron in your blood, the calcium in your bones, the carbon in every cell, the oxygen in every breath, all of it was cooked in stellar cores and blasted out in stellar deaths and recycled again and again through generations of stars until finally it became you. You are not separate from the Milky Way, observing it from outside. You are the Milky Way, a piece of it that gathered itself together and became complicated enough to look around and ask what it was. You are recycled galaxy. You are stardust that woke up and started taking notes. And the very fact that you can sit there and understand any of this, that the galaxy grew a part of itself capable of comprehending the whole, that just goes to show how strange and rare and precious this moment really is. So the next time you get the chance, when you're somewhere far from the city lights, in real darkness, do yourself a favor and look up. Find that faint band of light arcing across the sky, and know that you're not looking at a quiet, eternal decoration.
You're looking edge-on through the thin disk of a vast, violent, cannibal galaxy, 100,000 light-years across, hurtling through space, held together by invisible matter, spinning around a monster black hole, slowly devouring its neighbors, on a collision course with a galaxy bigger than itself. You're looking at the place that made you, out of the ashes of stars that died before the sun was born. You can see almost none of it, but now you understand a little more of what's hiding in that thin smear of light. And honestly, that understanding, that's the most human thing there is. We couldn't reach the galaxy, so we reached out with our minds instead, and we figured out what it was. From one small rock, in one quiet spur, we read the story of the whole thing. And that's the Milky Way, not a fixed, peaceful home, but a wild, half-built, ravenous, invisible-laced, star-forging, galaxy-eating marvel that you happen to live inside of, and happen, against all odds, to be able to understand. Turns out the calm band of light was the most violent and beautiful thing you've ever looked at, and you just didn't know it. Now you do. So go look up. The galaxy's been waiting 13 billion years to be seen, and you've got the eyes, and now the mind, to actually take it in. Thanks for hanging out on this ride through the Milky Way. Go find some dark sky, tilt your head back, and remember, you're stardust looking at the rest of itself.